so I will.
Yeah, the biochemist, the carbohydrates.
Oh, that's right. Biochemistry.
Okay, so I need to.
You want some more paper, Gudrun? To see it.
This is my lecture for this morning. That I must give it midwives.
Oh, thank you, Kiri.
Mine was closed.
Thank you so much.
So this biochemical carbohydrate one.
Yeah. What was the one we did last?
Last week we did
Pelvic.
oh yeah,
Muscle,
muscle and bones and pelvis.
Yes. Oh, I know, but I just. But you said we could ask questions, but we'll wait for you to hear because you'd like to listen to the pelvis stuff.
There's some biochemistry.
Yeah.
Is it?
Yeah.
Oh no, I haven't looked at this because I'll tell you, because I copied those pictures. Oh, because it's the primary, secondary, tertiary, and I go by pictures.
No, I agree with you. Okay, so
Couldn't quite do that one. Couldn't quite draw that like that.
so I will also go and check why they're not there, because I know for a fact that the other times Les, the guy, stood there and I pressed the buttons for it to record. So
Yeah.
like, I really don't know why that's not happening. Okay? So I will follow it up again. I beg your pardon?
Just not getting it. We're just not able to.
Yeah, okay. Now I'll go back now and sort it out, because again I'll find out what's happening there. Right? Okay. Okay. Just because you've got your page open there on biochemistry, shall we just talk a little bit? Shall we do that topic first?
We're doing both biochemistries or
Yeah, I'll sort of do both.
Is that like
The carbohydrate metabolism,
Carbohydrate,
fat, and protein metabolism. Okay.
out of all the little tests that I did online, that was the one that the hardest one.
Biochemistry, organic chemistry.
That's the
I just said to Nina that we time we got stuff we actually said we were.
yeah, she was having a bit of time, but she had
Yeah, she got
I don't know how much it's that from, who knows how.
So listen, am I starting or am I?
Please start. You start.
Okay, so let's talk about carbohydrates first. Okay. Okay, so carbohydrates are made up of what? Carbon, hydrogen, and oxygen. Okay, and this basic structure stuff is in chapter 3 of your Merriam. Okay, what you've got open in front of you there, right? All right. So, what is the basic building block of a carbohydrate? Okay, yes, it's made up of these, but what is the basic building block? Glucose. Okay. Okay, and then glucose and other 3 other monosaccharides can be joined together, and we're going to get complex carbohydrates. So this is a monosaccharide. Okay, mono one. One glucose is one monosaccharide. Okay. Let me do this while I'm about it. Okay, so glucose molecule has got this hexagonal shape. Okay, so as soon as you see that, you know that that's glucose, all right? Okay. If we then attach 2 glucoses to each other, what have we got now? We no longer have a monosaccharide, but we've got a disaccharide. Okay, we've got 2. Okay? And if we were to string more together, we'd end up with a polysaccharide. Okay? Poly, many. Okay, not 3, but many, okay? Right? drive home to Hamilton, buy myself a packet of lollies, and I promise myself to have 2 or 3, but of course by the time I get home, it's all gone. Okay. So, what has happened to my blood sugar when I get back to Hamilton? It's up, okay? Because I'm then going to eat dinner and that when I get home, can you see that I've got too much glucose in my system? Okay? So what my body is going to do is string them together, my liver, okay? It's going to string them together and make glycogen. Can you see that glycogen is a polysaccharide and it's purely made up of glucose? Okay?
So it only turns it to glycogen when it's going to be stored.
That's right. Okay, so therefore, we do not store a lot of glucose. Okay, so we've got too much glucose. We will change it into glycogen and we will store that. Okay.
And that just gets stored in cells, doesn't it?
Mainly again in the liver. Okay, but anyway, but the main job is this conversion takes place in the liver and that's where it's going to be stored. Okay? All right? So we find glycogen in animal cells, okay? And it's a polysaccharide, okay? The equivalent of that in plants would be starch, okay? And cellulose. Okay, so those are polysaccharides, but they are made by plants. Okay, and that is what we, of course, eat. I mean, we eat starch, okay? And we eat some of that cellulose, which is the fiber, that's part of our diet. Okay? Okay, you happy with that? Now what is going to happen? I haven't had breakfast and I haven't had lunch. What's happened to my blood sugar? It's go down, okay? Does my body like to have a low blood sugar? No. So what my body's going to do is going to break down this glycogen. What have I got now? I've now got glucose again. Can you see I've got 3 glucose molecules? Okay. So I've broken down the glycogen and now I've got glucose again. Can you see my blood sugar is back to normal? Okay. And that sort of balancing process is what we've also been calling homeostasis. Okay. So without eating, my blood sugar is low, so therefore my body is going to get glucose from glycogen. Can you see the balance is restored? Okay. When I go home and I eat my lollies, my blood sugar is up. Can you see that my body is going to convert it into glycogen so that my blood sugar is normal? Okay. It's always the blood that needs to stay normal. Okay.
Is that a negative reaction?
Okay, so that's a negative feedback mechanism. Okay, that's what we call negative feedback, okay? Meaning it negates everything when it's back to normal. Okay, happy with that? Okay. Okay, so what does the word glycogenolysis? Lysis means breaking up. Okay, so if
It's Brian from Gisborne.
And Colin.
that's fine. Okay, so lysis means breaking up. Okay, so if I've got glycogenolysis, I am breaking up the glycogen. Not so? Clear? Okay. What is glycogenesis? I know it is.
Now I understand what Genesis Power
Exactly.
is. Yeah, okay. My father's worked for them for years and years and years.
Okay, so anytime we have the word Genesis, we are making, so glycogenesis, I've got too many genesis there, okay?
I have to say, by you breaking down all the words, it's made things simple.
Yeah,
So much easier. It just makes it happen now.
That's right, but
Yeah.
you must always do that. I mean, I'm not smart, okay, but I do that. And you see, as you're asking me a question, of course I can do it quicker than you do, but can you see I'm just breaking that down and there we are.
It certainly makes
Okay.
it sink in easier for
Alright,
me.
okay,
It's
so-
something else.
Glycogenesis.
Making glycogen. Okay, everybody? Okay, you're right?
Mm.
Right, so we're talking about biochemistry and why do we have to eat this glucose apart from that the lollies taste nice? But why else? Why?
To keep our blood
Energy, okay? So we need all the foods, okay, to give us energy. And the way we get energy from glucose is that glucose is going to get broken down. And all these processes that we're talking about, whether it's building up or breaking down, there are always enzymes involved. Okay? And you don't need to know the name of all those enzymes always, okay? But there are enzymes, okay? Okay, so we need to break down this glucose into smaller particles, and that is going to release the energy. Not yet. Okay, step by step. There are three steps before we get the energy. Okay, so the glucose is going to get into the cell. Okay, what do we need for the glucose to get into the cell? We need insulin for the glucose to get.
That carries it.
Yeah. So we need insulin to get the glucose into the cell. And once the glucose is in the cell, we're going to have the first process of metabolism, and that is glycolysis. Okay. Okay, again, what have we got? Lysis, meaning breaking down. Okay, and this is where, unfortunately, it doesn't say glucolysis. Okay, it says glyco, but not glycogen. Okay, okay. So this is breaking down glucose. And for the glucose, we had 6 carbons. Okay, and what gets broken down is it gets split. So the end result of this glycolysis is pyruvic acid. And if I tell you that pyruvic acid has got 3 carbons, how many pyruvic acid molecules have I got? I'm going to have 2. Okay, so from every glucose, we get 2 pyruvic acid molecules. Okay, I mean, not the most important thing in life, but okay. You happy with that? I'm sorry, I don't have an answer. Did you write?
Yeah.
Okay, and this pyruvic acid is then going to be changed into the next thing, which is acetyl-CoA. Okay, acetyl-CoA.
Is that before it enters?
Okay, so basically that acetyl-CoA sort of in between, the acetyl-CoA is inside the mitochondria. Okay, so as it changes, then it's this acetyl-CoA is now in the mitochondria. Okay? Okay, and in the mitochondria, what we're now going to have is the Krebs cycle. Okay, so that's number 2, the Krebs cycle. Okay, and then inside the mitochondria, we're going to have the third thing, which is the electron transport chain. Okay. Okay, is there anything else that we need for this metabolic process to happen? Does glucose just do it all by itself?
Oxygen.
Okay, so we need oxygen.
And then that's aerobic.
Okay, we've got oxygen aerobic, and without oxygen anaerobic.
Am I right in saying that you said in the lecture about the Krebs cycle that we didn't need to know all the details?
Yes. Telling you, you know, the words that I'm saying to you today, that's
We don't
okay.
need to know all the
You
other
don't
ones
need
that
to know
were in
all.
that diagram.
Okay.
Yeah.
Because it's not that I don't want you to learn it, you're welcome to go and learn it, okay? But you're never going to see this in practice, okay? You're going to land up with women that are tired, so they've used up their energy. What are you going to give them? Glucose, okay? You're going to have women that aren't breathing properly and haven't got enough oxygen. Can you see that they can't metabolize? So that's the level that we're going to be interacting with this, okay? So this is just to give you a bit deeper understanding of what's happening. But we are not chemists or physiologists or so. I don't really need to know more than that, okay? All right? And I mean, I'm setting the questions on this topic, so therefore I'm not going to ask you anything, okay?
Oh, so you're not doing any of this now?
Yes, I am.
Cool.
Now,
Right, you can slap me, it's fine.
now I am, and at the same time, I am asking, you have to read the question carefully, okay? And if I use a word that you've never come across, that's, for example, not on the board today, the answer to that is probably wrong. Okay, but don't just like jump in and say it's wrong. Go through the questions carefully, but if in doubt, then that is probably the wrong answer. Okay, if in doubt, okay? So that's why, you know, but you do need to read carefully, because in this case, if you start making spelling mistakes, can you see that then glucose is glycogen and that's wrong, or glucagon and that's wrong? Okay, so I'm afraid you do need to get the spelling right and reading what we mean, okay? Okay, so we need oxygen, okay? Do we need oxygen for glycolysis?
Breaking down.
The breaking down of the glucose, do we need oxygen for that?
Yes.
Okay, the answer is
No.
yes again.
How would you guess?
Okay, so we can have glycolysis without oxygen, but of course it works better with oxygen. Okay.
And I was going to say, I just remember doing this last year, when it goes to each stage, and does it still capture some electrons later for the glucose, which was
Okay. Now, so if your woman is in labor and she's not breathing properly, she's not getting in enough oxygen. Do you agree? Okay. Can she, and let's talk active labor, can she be in active labor for a very long time?
Oh,
Okay, the
no,
answer is
no,
wrong.
no,
The answer to
no.
that is wrong. No, because she's going to run out of energy.
Yes.
Okay? Right? So therefore, and she's not breathing properly, so she's not getting enough oxygen. So therefore, you can only do glycolysis without oxygen for a short period of time. Exactly, and the problem. Now everybody's writing on this one. Okay. No, that's fine. Okay, so if you do not have, so if we've got anaerobic metabolism, okay, the waste product is lactic acid. and lactic acid is an acid, and if that builds up in our muscles, that's what causes pain. Okay, so a woman, and that is correct, when a uterus is contracting, that uterus is not getting enough oxygen, okay, and therefore if those contractions were to last too long, she's going to go into anaerobic metabolism in her uterus. Can you see that there will be lactic acid and it will actually cause more pain and damage? The uterus must relax in between to be able to get oxygen. Okay?
So if someone's having what we call back-to-back contractions,
Yeah.
if they did that for too long.
Okay, so it's best to have oxygen. Okay? And therefore, the end result of this, okay. Do we need oxygen for the Krebs cycle? Yes. Okay, so we need oxygen for the Krebs cycle. Do we need oxygen for the electron transport chain? Yes. Okay, so we can only do a limited amount of glycolysis without oxygen. So to get enough energy, we do have to have oxygen. Okay. Do we get energy out of the glycolysis pathway?
Only a tiny.
Only a tiny bit. Okay, so we do get ATP energy out of glycolysis. Okay. Do we get ATP out of the Krebs cycle? Okay, again, we do get some, but it's probably not a lot. Okay. Do we get energy out of the electron transport chain? Lots. They give me a duck pen. Oh, here's a one. Okay. What other substances other than the energy comes out of the Krebs cycles? Exactly. Okay, so the other thing we have coming out there is carbon dioxide. What do we do with the carbon dioxide? Breathe it out. Can you see? No problem. And again, it's difficult to notice on us actually, but if you were to eat a very high carbohydrate diet, okay, and eat well, maybe even when I get home after my packet of lollies, okay, I've got all this carbon dioxide being released. Can you see that my breathing will actually speed up a little bit? Okay, now I mean, we don't notice it under normal circumstances, but that is what happens.
Is that when you hyperventilate to that blow out of the
Well, you do, yes, that's right. Okay? All right, everybody happy with that? What's bothering you? Okay, so there you have carbohydrate metabolism. And carbon dioxide, and the other thing that comes off is water, but again, that's a sign because we recycle it. Okay, now we can do exactly the same thing with proteins. What is the basic building block of proteins? Amino acids. Okay, what makes amino acids different? It has got carbon, hydrogen, and oxygen. And what else does it have? Nitrogen. Okay, so nitrogen is in proteins, and that's why we do have to eat proteins. Okay, because again, urea. Okay, product, okay, and we excrete urea in our urine. So if we're constantly excreting urea, can you see we constantly need to eat nitrogen, otherwise we're going to have a deficit, a shortage. Okay, so again, whether you eat proteins from plants or proteins from animals, it doesn't matter, but you need those proteins. Okay, so we're going to have, again, we're going to have those amino acids get into the cell. Okay. It will undergo glycolysis. It will just do it a little bit differently, okay? But it will undergo glycolysis. Okay. And at the end of glycolysis, we are still going to get pyruvic acid and acetyl-CoA. Okay? They're just different pathways. So when I've got acetyl-CoA, am I going to have the Krebs cycle? Yes. Am I going to have the electron transport chain? Yes. Okay. Am I going to have a little bit of energy come out there? Yes. Am I going to have a little bit of energy out the Krebs cycle? Yes. Lots of energy out of the electron transport chain. But again, I started off with a different product. So I am going to have a different waste product. What's the name of the waste product? Urea.
Does that come out of the Krebs?
No, come mainly out of, apologize, Krebs cycle. Okay. Again, the same principles. We need the oxygen and we need the oxygen there as well. Well, I also go to bed with my if you've got the new Marriott, but in the old one is also somewhere along the, and a little bit more in depth, this metabolism is in chapter 24. Okay, and on this on page, it's figure 24.3. And if you look on there, I mean, I know you haven't got it all in front of you, okay? But if you look in there, in the middle, it's got the glucose and the glycolysis. And do you see how the protein just comes in the glycolysis pathway and then the acetyl-CoA? You see, so it just goes a little bit of a different side step before it enters. Okay? So therefore, as I say, the steps are the same. Okay, and the same with the fatty acids. Can you see the glycerol, which are glycerol goes into the glycolysis pathway, the fatty acid there. Can you see it's all the same process?
Then you get amino acids go on to you, but they also go on.
Yes, they okay, but I mean,
But they mainly go to
but I mean, I just go one path because to me,
gotcha. So they mainly go all into that one.
yes, that's right. And the fats also go into the, so we all end up with acetyl-CoA, okay? Right, you understand? Everybody happy with that? Okay. Let me just show those ladies at the back what I mean. And, no, they've got a book. Okay, so proteins, amino acids, they also go a little bit into this glycolysis pathway, a little bit later on, depends if all intents and purposes are the same. And the fats also, fat glycerol goes in there, and that goes in there. So at the end of the day, it's glycolysis and then Krebs cycle and then the Krebs cycle. Okay, so that's important. And then, so this diagram does exactly what I'm doing on this slide. Glycolysis, Krebs cycle, and then don't worry about it. Okay, all right, so we've we've done proteins and carbohydrates. What about fats? Okay, what's the building block of fats?
I remember the omega-3 thing was the third one along, and the sixth one along, but that's probably not important.
Well, it is, but I mean, then now you know why we talk about that, okay? So, the most common fat is triglyceride. Okay? 3 fatty acid chains and 1 glycerol molecule. Glycerol, okay? Okay, that's why I'm saying you need to get your spellings of that correct here, okay?
And one, is it one glycerol?
Sorry, yes. It's 1 glycerol molecule, it's got the shape of an E, okay? It's carbon, 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 all like that, okay? That's why I draw an E like that.
3 fatty acid molecules.
Yes. Or chains, then you remember that they're like tails.
Yeah.
How do you say it? Is it dry?
Oops, thank you. Glycerol.
Yeah.
Glycerol. Have you all got the spelling right? Thank you.
So the building block of lipids is 3 fatty acid molecules and 1 protein and 1 glycerol.
Yes. Okay. So. Okay, so for all intents and purposes again, okay, the triglyceride molecule gets into the cell. We're going to have glycolysis, okay, and we're going to land up with pyruvic acid and acetyl-CoA. We're going to have our Krebs cycle and our electron transport chain. Can you see nothing new? And because we started off with the triglyceride, okay, again, in the Krebs cycle, the waste product is going to be something different, and in this case, the waste product is ketones.
So that's exactly right.
Okay?
So ketones, the waste product of the Krebs cycle?
Ketones or ketone bodies. Okay? And again, I didn't use this word, but I'm telling you now. Okay? So ketones or ketone bodies is the same thing. Okay? What's a totally different thing is a keto acid. Can you see it's got this acid word? Okay, so this has got nothing to do with it.
So can you get ketone in your urine?
Exactly, that is this.
And so what would that mean? Like if I'm
Okay, so that
having
means-
infection.
No. If you've got ketones
Yeah.
in your urine, that means you've got too much ketones in your blood. Where does ketone come from?
So you've
So-
eaten too much fat.
Okay, so theoretically, you have eaten too much fat.
Yeah.
Okay? Having said that, that again will be a normal process and we'll get rid of those ketones. Okay? What happens to diabetics, they have got no insulin. Therefore, they cannot take the carbohydrates, the glucose into the cell. Okay? But the cell is hungry. So what is the cell going to do? The cell is going to break down lipids and make a lot of ketones. So diabetics have got a high blood sugar because it can't get into the cell, and they've got high ketones because they've utilized their fat.
And if you don't eat, you get
That's
ketones
right.
in your urine as
Okay,
well.
so therefore again, if you're going on a diet and you're not eating, okay, not eating anything, you know, then again, first of all, you're going to have your glycogen broken down, okay? And when that gets broken down, you're going to start using your fats for energy. And you'll have ketones, and you've got that ketone breath. You know, funny, I don't know how to describe it, but it's sort of a ketone breath, okay? And therefore it's so important that you drink enough fluid because, again, these are a little bit acidic and you don't want them to accumulate in your body. You want to wash them out, okay? So if you have got that ketone on your breath, again, check out whether you've got diabetes, or otherwise drink lots of water that you wash it out. That's it. Okay. So they all follow exactly the same process. We start with something different, and basically all we've got is a different waste product. Okay. And the amount of energy that we get when a triglyceride is broken down is just about 3 times as much energy as we would get from 1 glucose and 1 amino acid. Okay? So you just get lots more energy because of the structure. Okay? Right, you okay with the biochemistry part there? Okay. So again, read your words carefully. Glycerol, glycogen. Okay, did Ricky use the word glucagon? Where are my pens? Okay, so glucagon, you see, glucagon. Okay, glucagon is a hormone. What does it remind you of? The word. It does remind you of glucose, okay? Okay, so on my way home with my lollies, I've got too much glucose, and therefore my pancreas is going to make a lot of insulin to take that glucose into my cells. Okay? Okay? The moment my blood sugar is low. Okay, can you see we now need a hormone that is going to tell the cells to start that. We're going to need a hormone to start the cells to start the process of glycolysis. Okay, and that hormone is glucagon. Glucagon brings your blood sugar up. Insulin brings it down. Okay, any other questions around biochemistry? Okay, you all happy? Right, what did you want to tell us? Okay, what about pelvis?
I was the whole lecture because our household had food poisoning, so I don't make Monday or Tuesday. So, oh, it's online. You can try
Was that
what was covered on Tuesday? Because I think what was
Muscles. That's not on the test though, okay? On Tuesday I did immune system and the renal system, because when you come in for your test next Tuesday, you can have the test for an hour and then you've got labs Okay, and then is the renal dissection, so that's why I wanted to make sure I did the lecture beforehand, okay? So, but what I did on Tuesday is not in it, okay?
So we need to know the scale. Well, we do. We need to know all that, don't we?
But my question was, all these muscles that were in it, these, do we need to know all of these?
Okay, so,
Eventually or now?
all right.
I don't mean that
Oh,
way.
quite mean, I'm teasing. Yeah. Okay, the question is about the pelvic diaphragm. Okay, so again, of course, the pelvic diaphragm is important for you. Okay, and I mean, it keeps everything in, and that's where the vagina comes through. So again, that's part of your birth canal type thing. Okay. Now, every picture, and I've been trying for 3 years and more to get a decent picture of the pelvic diaphragm that I personally find suitable. Okay, they either show properly the urogenital diaphragm or properly the anal one. Okay, and I cannot get the two together. Okay, so therefore again, there are lots and lots of muscles involved. Okay, so who's got a hand open on that? Okay, so on the diagram that I've given you of the pelvic diaphragms, okay, so the anterior one is the urogenital diaphragm. Okay, so uro refers to? Uro refers to? Urology, renal. Okay, so which hole opens up in the urogenital triangle? The urethra, urogenital. Can you see there you've got one muscle, the external urethral sphincter. Okay. Okay, so this is anterior and posterior. Okay, don't go paging through your books because then you're not concentrating and you're losing out, okay? Okay, so if we're looking at the pelvic diaphragm, the anterior pelvic diaphragm is the urogenital diaphragm. Uro, because that's the urethra. Okay, and therefore one muscle here is the external urethral sphincter. Okay. And the other big muscle is like a cross here. So what does a cross mean? Another word for a cross? Okay, lateral, you're quite right, okay? But also transverse, okay? So therefore, this muscle here is the transverse muscle. It's perineal muscle. Okay, again, it's logical, okay? And in the posterior triangle, it's called the sorry, what's it called? We're missing a word here. Lower down, where's your higher upper one? I don't think it's called this, but anyway, hang on. Did I not? Oh, there you go, a pelvic diaphragm. The bottom one's called the pelvic diaphragm or the floor, okay? So, okay. But I mean, again, if you look at the back, what hole is there? The anus, okay? So one of the muscles of the posterior triangle, which is also called the floor, is going to be levator, lifting up the anus. Levator ani. Okay, so if I say to you, where's the levator ani? I mean, you know where the anus is. Okay, so. Oh, you've got that one there. Okay, and the other one is ischiococcus. Ischiococcus. Okay, but again, you know, yes, you need to get your tongue around it. Okay. Okay. Where are the ischi? I mean, this is just to say it. Okay. Where the ischial tuberosities? Oh, no, sorry, not ilium, ischial. Yeah. So where the ischial tuberosities? That's what you're sitting on. Your bum. Okay. So therefore, the muscles are going from the ischium. Where are they going to? The coccyx. Where's that? Sort of like that, and this is the anal muscle. Okay. And yes, again, that muscle consists of 3 branches. Okay. But again, yes, later on learn them. Okay. But at the moment, that's okay. At the moment, that's those 4, okay? And the day that I find a nice picture that I can understand, then you have to learn them all, okay? What's it?
Don't keep looking for pictures.
I cannot understand it. You know, it bugs me. And then, of course, once I've given the lecture, I don't have time to look again. And the next year, I start looking again just before the lecture, and I just can't find one. Okay, so we're sorted with the diaphragm? Okay. And that is, again, what all those pelvic, and I know you're starting to see the head, okay? Yeah. That is what all those pelvic diameters are. They tell you, I mean, you need to know from where to where they go. Okay? We are only meaning, as midwives, we are only interested in the true pelvis. Okay? And what is the entrance to the true pelvis called? The inlet or the brim? Yes, yes, yes. Okay? The inlet or the pelvic brim. And if we looked at it from above, okay, it will look a bit oval shaped. Not a squashed oval, you know, quite a round oval. What do we call this passageway? If we talk in bones, okay? That's the pelvic canal. Okay. And what is the bottom, the pelvic? Okay, the pelvic inlet takes the baby in, it goes through the canal, and then it goes through the outlet, up. I beg your pardon? Okay, so if we looked at the brim from above, it's quite oval. If we looked at the cavity or the canal, it's literally round, okay? And if we looked at the outlet, just hang on a minute, I just must get this right. Yeah, just want the triangle. I mean, just yours is quicker to find, so. shape is diamond shaped. Okay? So if we wanted to take the measurements, our main concern, of course, is that it must be big enough for the baby's head to go through. So we are, for all intents and purposes, interested in the narrowest part. Okay? What diameter is the narrowest at the inlet?
Superior,
Okay?
anterior, posterior.
Anterior, posterior. AP diameter. Can you see that? That's the narrowest if you look at the shape. Is there a problem with size or so in the canal? No, because it's round, all diameters are going to be the same. Okay? And when we get to the outlet, it is the transverse diameter that is the narrowest. Can you see we'd be concerned about that one?
There goes that hole I thought I've got in, that's going to get out. No. No, if it got engaged and it was got in the inlet, it's going to get out the exit. It doesn't, it gets stuck.
Sorry.
I just took that from
Smaller.
How do I take that one?
I knew what I knew.
I knew what you mean, only because I know what you like.
So what we need to, and what you now need to do is you need to learn from where to where do those diameters go. Okay? So in the brim, okay, what is, oops, sorry, I'm wrong.
I never quite worked out what that picture was.
You haven't. You see that maybe I don't need to find your picture because you don't understand my pictures. Okay, so here's the pubis. Okay, so now anterior is the second, okay? Okay, here's anterior. Here's the pubic bone at the back. I've got the sacrum, and then there's a joint between the sacrum and the coccyx. Sacro-coccygeal joint. Sacro-coccygeal joint.
That's inlet, canal, outlet.
Yep. So therefore, this is going to be the inlet, this here's the canal, and this is going to be the outlet. Okay? So therefore, if I'm talking anterior, posterior, okay, what is the margin of the end, if I'm talking brim, okay, what is the margin of the anterior brim, part of the brim?
Pubis.
The pubic. Okay, the pubic bone is the anterior, okay. What is the end at the posterior end? Okay, what, something is special where the lumbar vertebra joins the sacrum. What is special there? Okay, this first sacral joint, this first sacral vertebra is actually quite thick, so that's called the sacral promontory. And again, on this picture, my fingers definitely aren't long enough, okay? So if you stick your finger into the, I mean, it's all professional and all the rest of it, okay? Put your finger into the vagina, okay? Again, and you like hook therefore around the pubis, you should with that finger be able to feel that point. Okay, so I'm out of size, but I mean, look, okay, that sticks, because you can go quite deep in under the pubis, and then if you tilt it backwards, okay, you can actually, honestly and truly, feel that sacral promontory.
So far away.
So it's that.
That's why, sorry, that's why if you take a real pelvis, that's why I wanted you that day, and if you stick your finger in like I've said now, this is out of proportion, okay? My fingers were just too short always when I was doing my midwifery. I could just not get there.
Can I borrow your finger? I've
No,
got this
just-
thing that I think my fingers are too small.
One says, so again, it's measure from here to your fingertip, okay? And if what is the AP diameter of the? No, we need. So if you can measure what this diameter is, and if you can therefore reach, and you see that, let's say this was 11 centimeters, okay? And if I can reach that, that means that diameter would be 11 centimeters, okay? But like I say, I could generally not reach because my finger was just too short. Okay?
I'm pretty worried about this.
We don't have to do this anymore, though.
Most of the time, you are not going to be doing per vaginal examinations to find out the size of the pelvis. Okay, these days they do that with ultrasound and things like that. Okay, when you may do it is to be able to feel the cervix. Can you see that that is far lower down? So you will get there. Okay, and the baby's head to feel whether it's in what position it's lying. Can you see that that's lower down? Okay, so most of the time you will be able to reach there.
Yeah.
Okay, and you're not going to be doing lots of pelvic examinations.
So when would we have to do the pelvic examination?
Well, look, I've done midwifery for years,
Oh,
okay, so I don't have a common practice. But again, if the woman is in labour and you don't know whether she's dilating or not, okay, so you may check for the cervical dilatation, okay, and as I say, if the baby seems to be stuck, you may want to feel, because you can feel the sutures.
Yeah.
Okay. So again, it is in, let me say, emergencies. Okay. It's not a routine practice anymore.
That was like, I remember when my nephew, my little cousin when my auntie fell pregnant with him. Is that when they go to the doctors?
Yeah.
Back then, and then it was like, I'm pregnant, and then they did it then?
No, yes, they would, because if you're only just pregnant, and remember this was before ultrasound, okay,
Yeah.
which is not that long ago, okay? But again, so then they would have measured, because the uterus is still small. Can you see you can reach there?
Yeah.
Okay, once the fetus is there, that is quite difficult to reach there. Okay, so
Yeah.
that's why they used to do it
Yeah.
early in pregnancy, and they can sort of get the sizes, and then again during labour to determine whether there's dilation or not.
Do they used to tell about whether someone was pregnant due to the coloration of the cervix?
Yes. Look, there are lots of ways of determining whether you're pregnant. So the cervix and the vagina gets a lot more bluish. It's much more. There's more blood there. Okay, and also the cervix actually does get softer. Okay, and yes, towards the end of pregnancy even more so. But the cervix changes a little bit in texture. Okay, so I mean those are some of the signs, and then they can do. Also, they don't do that anymore. Is like squash the uterus, take the uterus, they go in above the pubic bone and feel the uterus. Okay, but again, that needs the woman to be very, very relaxed. So again, ultrasound stops all those interesting things.
So this might sound a really silly question, but this is the uterus with the baby here and it's coming down.
Yeah.
I just couldn't understand this picture.
So
Is that the same thing?
that's right. So
That's a much better drawing, much better picture for me anyway.
So that's it like that, isn't it?
I think what
Yes.
Yeah, and this is the one, is what the dotted line is doing.
Okay, okay, because wait, there's more. Because that diagram is because wait, there's more, okay? So I was just generally saying to you that the pelvic rim anterior posterior diameter goes from the pubis to the sacral promontory, okay? In actual fact, can you see that I've drawn it to the tip there? But is that the narrowest part for the baby to go through that past the pubic bone? And you see that sticks out. So I actually need to measure from there to there. Okay, so that is still the AP diameter, but because we now got these different ones, that's where we talk about the conjugate and the true, the gynecological diameter is the one that we need to use because it's the smallest. Okay, and this is the anatomical one. So anatomically, that's the opening. But from a gynecological point of view, we need to take that little bit off because that pubic bone goes to the inside. Okay? So that is why you've got those three lines raised at the top. Okay? So you've got the inlet, you've got the top, which is the anatomical one, and that is the gynecological one, okay? And that is the diagonal conjugate. That is the one that you're measuring when you put your hand in. Can you see? It's still the AP diameter, but it's not quite at the rim. Okay. Okay, does it make sense? Okay. So yes, those are important, and you do need to know those landmarks. And the outlet, again, the diameter goes from the bottom of the symphysis pubis to the sacrococcygeal joint. Okay, sacrococcygeal joint. Okay. And that one, but it could also, of course, go from the pubis to the bottom of the coccyx. Okay, those will both be outlets. Which one are we interested in as midwives? Okay, the transverse one, which is across here, but out of these two, the smallest one, which is the red dotted line, okay? Because so that's the gynecological outlet, the red one. Okay, and the other one is the anatomical one, because that coccyx can move. Okay, so the baby's head could move that coccyx out of the way, and that opens up the diameter more. Okay, but that, the bottom of the sacrum can't move, so that is the smallest diameter it has to fit through. Okay. What else was done? Drew there.
Makes a whole lot more sense on here than it does on that VCR.
I know. It is always also easier the second time.
Oh yeah.
But yes, I must. I wouldn't.
So do we need to learn the fetal skull diameters as well?
Yep. So and then now you need to do exactly the same as the fetal skull. Which way is your baby pointing? Okay, so again, we need to know the diameters of the fetal skull, and that means you need to, oh, that's a very analphabetic child. Okay. Okay, the other name for the posterior fontanelle? other name for the anterior fontanelle? Bregma. Okay.
It's not an artist, I don't need that on my own. I think that's a apology. Put down I got kicked out of art the first day, okay?
So if I've got a mento, what about mento? I just want to use the same mento, vertical. Can you see that? That's the diameter from the mentum to the vertex. Okay. So that's the point of the chin. Okay. If I go a little bit back, it's called submento. Okay, it's just underneath the chin point. So submento bregmatic goes from the submentum to the bregma.
Is that saying it would come out?
I beg your pardon?
Is that saying it would come out with its face?
Okay, so again, in this case, that's right. Okay, so this one is going to come out, and a little bit that one, okay, is going to come out with the face, and a bit, and this one probably more with the brow also. Okay, so yes, these are dangerous face presentations. And you can see how, I mean, right, my baby's drawn wrong, okay, so.
You did tell us a really good story about a baby that, did you hear that day? Oh, she was delivering a baby, and another lady was in the other room, and the lady was going home, and she said, "Can you be the second for this lady?" She said, "Yeah, yeah." And after a while, she thought, "Oh, she hasn't called me in." She went in there, and it was that face presentation like that. And she said by the time she said to the other lady, calling in as well, but when the lady contracted, she managed to push the head down so it did arrive, but she said it could have ended up the other way.
That's right.
Yeah.
Again, that is, well, again, that's why it's important to know what the presentation of the baby is, because if it's in the wrong presentation, if it's quite high up back into the pelvic canal, okay, if it's quite high up in the pelvic canal or even before it gets in, can you see one can then twist it a bit or bend the head, that it can easier, just a little tilt makes a big difference. All we need is a centimetre just to get that.
Actually, wonder now, I remember when I had my daughter, she had her sucks out, but I had 5 different people try and feel what position she was in. So she was obviously way with the fairies, but she must have been in a weird way where none of them could work out what position she was in. So, and when they sucked her out, the volunteers ended up being over here.
So that's not too unflexed.
She had blisters and everything in there. So.
Okay, what have we got another? We've got an occipito bregmatic, haven't we? From the occiput to the bregma. Oh, no, it's not one of the ones there. Okay, but there might, there could be one, okay? Oh, that's actually suboccipito, okay? Suboccipito is just underneath the occiput, okay? But again, that's where the words tell you where it is. So if I say to you, submento, okay? So there's another one on the list here, submento vertical. Okay, so where must I start? Okay, submento. Okay, underneath the mento. Okay, and then vertex. And she's that thing.
What you say, if you know the name, how would you work it out?
And I mean, that is, if you spend the time learning those words, and yes, you need to learn them, and you need to draw yourself a diagram of the stuff that makes sense to you. Okay, like you may, which is fine, you may not like my diagrams. Okay, draw your own, get in those key words, learn those words, and then just listen to what people say or read what we're asking. But you can read it. then it's just a mix and match situation.
What is that top one?
Sub-occipital.
Oh,
That's this one here. This one should be sub-occipital. Okay, so I mean the occiput is this whole bone. Okay, so it's the bottom part of the occiput. Okay, so it's sub-occipital rhegmatic. Okay, and that is the sub-occipital rhegmatic. Okay, so that's one of the smaller diameters. Okay, so the sub-occipital and submentabregmatic, those are probably the sub-occipital. Which one did I say was the best one? I mean, this one definitely sub-occipital bregmatic, okay, is the best one.
So the bregma, would that be roughly the soft spot?
Not roughly, it is.
Oh,
Okay, so the anterior this is the anterior fontanelle. So this is the soft spot that you feel here, and the anterior fontanelle is much bigger than the posterior fontanelle. And therefore the posterior fontanelle also closes earlier than the anterior one does.
So when it says frontal, like
Occipital frontal.
is that the face?
Yeah, that is again to the brow.
Oh, to
Okay,
the brow.
so some of those have not got a definite spot. Okay, so this is to the brow. That biggest spot is that one. Okay. Okay, what else can I help you with?
Homeostasis, they were speaking about before.
Want to work out positive think contractions, you have to have it to have a baby. And the same with a cut, you have to pop to make it. So I worked it out that way.
Okay, if we're talking about homeostasis, meaning we want to keep our body in balance. Okay, and I mean, we constantly, at any one point, we're sort of a little bit out of balance because we either just eaten or we're hungry, or we haven't been breathing properly. So can you see, I mean, we're constantly moving. But our body wants to constantly get back to this balance. Okay? So therefore, except for lactation and blood clotting and delivery, and all the other mechanisms are negative feedback mechanisms. Okay, so therefore this is the most common one.
So, for those three, for the positive, is that literally the only three? Or is that just pregnancy related? Because I get the negative,
Yes.
but then when I'm trying to make an example of the positive, I'm trying to think of a non-pregnancy related one.
Okay, the blood clotting is the only one. That's non-pregnancy related.
So it's really, really rare.
Oh, yes. And it's a purely a safety mechanism. Okay? Like, if we had positive feed mechanism, can you see that the stretching of the cervix increases contraction? Stretch, increase contraction, can you see that that process, because it's self-perpetuating, okay, can go out of control. It's like a train. It's just going to more stretch, more contraction, more stretch, more contraction. Can you see? It can run out of control quickly. While a negative feedback system, as soon as the balance is restored, it stops. You cannot get overbalanced. So this is a lot safer. All right.
Can you just say again what the positive feedback ones were?
Okay, I mean, labour is one. Lactation, because the more the baby sucks, the more milk you make. And then blood clotting. Okay, so we're going with blood clotting, okay. More and more chemicals, more and more clotting. Can you see that if that goes out of control, you're going to have one massive blood clot. Can you see it's dangerous? Okay. Going back to my lollies, and I will then use another example after that, okay? But going back to my lollies, which I've just eaten on the way home. Okay, can you see that increased glucose in my blood? That is the stimulus. That's the wrong thing. Okay? And that is going to stimulate receptors. With other words, it's going to stimulate network that is going to receive this message that I've got high blood sugar. Okay, and in this case again, those receptors are in the pancreas. So as my blood flows past the pancreas, they're going to be little antennae, and they're going to say, oops, too much sugar. Okay? In this case, again, it's very straightforward. It's going to go to the control center, which is also in the pancreas. So the pancreas is both. But it's not always both, okay? So the control center is now going to pick up the message and going to say, yes, the blood sugar is high. And the control center then is going to say, well, what must I do about it? Okay, so the control center gets the message and works out what to do to correct it. And they're going to again say to the pancreatic cells, make insulin. Okay, and again, this happens to be now in the pancreas again. Okay, sorry, insulin. And then the insulin is going to go to the cells, which are the effector in this case, cells, and the insulin is going to take the glucose into the cells. Can you see that that is the effect? Oh, this is what I wanted. Insulin is the response. I knew there was another word. Pancreas, control, response. No. Effect, response. No, it's the same. Effector or response. Okay, sorry. No, I was right. Leave your, don't rub out anything. It was okay. So when the insulin, when the glucose now is in the cell, what's happened to my blood sugar? It's now back to normal. Okay. So when my blood passes past the pancreas, so when my blood now comes past the pancreas, what's my pancreas going to say? My blood sugar is normal. Okay, so can you see there's no stimulus? Okay, am I going to, the receptors aren't going to be stimulated because there's no message, okay? My control center doesn't have to work. Can you see I'm not going to make insulin because I don't need to, and my cells aren't going to get extra glucose. Can you see? The mechanism stops because there's no message anymore. Okay? And so if I eat my packet of lollies and my glucose has gone up and I've now taken it all into the cells, okay? That is where homeostasis stops. And our body is so clever that it will not by accident make too much insulin Remember we have the insulin here? Okay. Our body will not make too much insulin that the blood glucose level drops.
But could there be some sort of disease?
That's exactly. So disease, that's the thing. Okay. So under normal circumstances, a normal person, the negative mechanism stops. And that is when you've got a disease, which means that mechanism is not working perfectly for whatever reason. Okay, and that is what happens in diabetes. Okay, there's a stimulus, high carbohydrates, glucose. Okay, it'll tell the pancreas that it's high, but can you see there's no effect? That's a disease. Homeostasis cannot be restored. Okay. And if we now give a patient, because you can give a diabetic insulin, and you see if we give insulin, we can give too much. Now the blood sugar level will drop. And that's why insulin is so dangerous, because the homeostasis in our body is not working. And therefore we can only overdose the patient with insulin.
How much do you need to give?
Right, that is totally dependent on every person. That's why they test their blood sugar regularly, and then they adjust the insulin. So again, some people may need 10 units of insulin to keep the blood sugar level, others may need 2. Okay? So again, that gets constantly, like we call it a sliding scale even, we're constantly sliding up and down the scale, giving the person different amounts. And that's the tricky part. Okay, Casey, our life's easy. Okay, it's all done for us. Meaning if we haven't got diabetes.
Diseases was diabetes, type 1 diabetes, isn't it? It's one of the worst ones. Yeah, just for the
Yeah.
hardness of it.
Yeah, because the diabetes one has got just about no insulin, so that's very dangerous, okay? And your ladies can get gestational diabetes, okay? So they're going to have this homeostasis go wrong only while they're pregnant. And as soon as they've had the baby, they'll go back and be normal.
So when you have gestational diabetes or any diabetes, is the homeostasis only affected by the insulin, nothing else?
Correct. Okay. Okay. So there is more to it, because of course, if there's no insulin, all the cells are going to be affected. So can you see how a lot of other things are going to happen as a result? Okay. But it's this one mechanism that's gone wrong, and only in one little place. But can you see it's a crucial place? Okay. So therefore, every disease has got a different part of homeostasis or whatever gone wrong. Okay. Okay, if I use another example, okay, I'm dehydrated. Okay. With other words, I've got less water. Okay. So I've got less water, I've got less blood circulating. We have receptors called osmoreceptors. Okay, what are they going to pick up? Okay, the osmolality, the amount of water, osmosis, water. Okay, so these receptors are sensitive to how much water, with other words, how concentrated your blood is. Okay, they are found, amongst other things, in the hypothalamus. And the hypothalamus is also the control center. And one of the things for the hypothalamus is then going to say, I need anti-diuretic hormone. that antidiuretic hormone, some of the books say it is made by the posterior pituitary gland, but it's secreted there, okay? But it's actually made in the hypothalamus, and then it comes out from the posterior pituitary. I know we haven't done endocrine, but that's coming up soon, okay? The response, in a way, is that this hormone is made, and this hormone is going to go to our kidneys. Okay? And again, the word tells you what is the hormone called. Antidiuretic. Diuresis is making more urine. So what is this hormone doing? Saying to your kidneys to stop making so much urine. So what's going to happen to your blood volume? If you're not peeing so much, so we're going to have less urine. Can you see we're going to have more water in our body? Okay. And as soon as that water level is back to normal, there is no stimulus, so the receptors won't respond. The hypothalamus doesn't have to think, it doesn't have to make any diuretic hormone. Can you see that? But once the balance is returned, the system stops working.
What was the effect? Was that the kidney?
The thing is, one can argue the effect, or could be the fact that antidiuretic hormone is released. That's the effect, okay? And then the function of the antidiuretic hormone is to make less, okay? So whether you put both of these under that heading, that's fine, okay? Okay, makes sense? Okay, anything else I can do?
I was going to ask you, during the bone formulation, use that, and I was looking at the, you know how there's the ossification when
Yes.
the bones are being made. There was two, you know how there's
Two types of ossification.
yeah,
Okay, intramembranous and
yeah, because the one in my textbook, my married textbook, I've got the new one,
yes.
and I was reading about the which one was it? The second one. I think
Endochondral.
yeah, that one.
Intramembranous, yes.
And then it said it was the same, but there was no sort of diagram. It just had those two.
I know.
So is it the same? Does it start off the same? But
That's it, yes.
yeah.
So if you've got bone, is first cartilage.
Like the shape.
Yeah, okay, so that, how should I put that? Okay, so when we're trying to develop bones, these like long structures or whatever, okay, initially they are all just cartilage. Okay, so therefore we need to now make this cartilage into bone. Okay, and that is what we mean by ossification. We're making bone. Okay. Now, if it's a very flat bone that we're making, then again, the ossification is going to just start here in the membrane. And can you see, and once it grows in, then the whole bone will be ossified. So it sort of just grows from the membrane, and that is what happens in our scalp because it's quite thin. Okay? When we're talking about, there's not only so long. If we're talking about a long bone, it's quite difficult. Well, the long bone also needs to grow.
Yeah.
Okay, so therefore to have membranous calcification, then the bone is going to be stuck in the shape, and the child is not going to be able to grow. So therefore there has to be a different process of getting this cartilage into bone. Okay, so again, I'm sure there's a bit of membranous ossification, okay? But generally the ossification starts here in the center, that's why it's called the primary ossification center, and the ossification spreads a bit like that. Okay? When the bone, Right, let's make it like the bone is like that. Okay. So can you see it spread? Okay, but it actually gets quite difficult to spread from this center to these ends. Okay, and never mind when you want to grow even more. Okay, so therefore at some point when the bone gets a specific length, we make the secondary ossification centers. Can you see now it's going to ossify from here? Okay, and on both ends.
And so those all sort of happen throughout growing the child.
Exactly, that's right. So this one sort of peters out quite soon because it's run out of space, can't go anywhere. Okay, so now when the child grows, it grows at the ends of the bone.
Ah, okay. So those the ones at the end of the secondary. What are they called? Places.
And most of the growth is pushing the front out. So can you see that that part gets pushed out? You see that that part gets pushed out, so you can push forward like that all the time. Okay, so that's why you grow at the ends, and that when you reach adulthood, that sort of stops growing. That it actually doesn't stay a round thing. I mean, it becomes like a plate.
But that makes sense. I like your conclusions.
What is it?
I'm a picture person.
Who was the? One of the distance students said when I finished that revision, I said, Gudrun, can you always teach like this? Was it you guys?
Yes.
Was it you guys? Oh, yeah.
I'm a real picture.
We could have them like that all the time.
Well, I mean, I'm happy, you know, and if I know that, then I can use, I will prepare some diagrams a little bit better that you understand it, but it's the development of the diagrams that's so important.
Yeah, instead of them just being
Just there, and then again, with that small cursor, you can't often see where I am. You know, I know where I am,
You
you
just
can't.
said that,
So-
the primary and secondary, how you explained that, probably saved a whole half an hour of something you
Yeah.
talked about. That I can't say what I actually say.
No, I know, and I'm quite happy if we will give it a go to do a bit of a mixture.
Those pictures when you were drawing that,
Yeah.
it's really clear.
It just
Okay.
makes sense so quickly, step by step.
That's fine. No, I will do a bit of that. Because I mean, I enjoy teaching like this, you know. Everybody thinks I'm old-fashioned.
Oh,
Yes,
so
I
it's
am.
always the way. You can still
Well,
work
that's
with
better,
barriers
'cause-
off.
I mean, the technology these days, there's just too much
Well, you see,
of it.
there's too much of it.
Yeah.
I mean, I'm not anti it, but there's too much of it. Everyone makes such a hype of it. Okay, what's wrong with this?
Absolutely.
I mean, you know, most of you are happy. Okay, most of you've learned something. Can you see that?
Yeah.
I sort of think
Not a lot
though,
of
at
it
the time,
today.
our kids only learn through computers. They're not going to understand this because they've learned
But-
maybe today. I don't know.
Yeah, and that is where we need to have a mixture because everybody learns different, whether you're old school or new school, okay? So therefore one needs to have a mixture. But again, it's like, I cannot proofread something on the computer.
No,
I just cannot see it, I have to print it off. Now, I mean, you know, other people, that if you've grown up with computers, well, you can read much easier on them, you know. But anyway,
Well, I grew up with computers, but I still find it easier to.
Yeah, same.
I grew up on a blackboard, so.
I have to say, I prefer the whiteboard, I hate that shape.
Oh, yeah.
Oh, they-
Whiteboard.
You know
we
what?
used to do it for fun. It's like it's not fun.
I don't think we had laptops when I was
I think primary school
we
did.
Ours have
And a big
computer
roll
screens
like
now. Yeah.
Oh, yes.
And so do they, yeah.
Take your own device to
And then you got the duster thrown at you because you weren't listening.
Oh.
Or your punishment job
Oh,
is
okay.
dusting.
Okay, you guys, have you got anything else in mind?
That's right.
Thank you very much. Also there.
And if you were going to eat lollies on the way home, what sort of lollies would they be?
Ah. You know which ones I actually quite like? I mean, well, the chewy ones, but I don't know what the one name is, but I do like these, the ones that haven't got artificial flavouring.
Oh,
the
natural
Yes, they are quite nice.
We just wondered what lollies you'd eat on the way home.
Hopefully there'll be some left when we get there on Tuesday for our test.
Thank you.
I'm on a budget at the moment, I'm not allowed to eat lollies.